This lesson will be on using the TI-30 calculator to perform calculations using scientific notation, and we'll do a few different types of calculations. A further lesson does more advanced calculations. For our first sample problem, we just want to divide 1.40 times 10 to the 5th by 17. Our keystrokes for the calculation are 1.40 second, EE. The last two keystrokes have told the calculator that the number will be in scientific notation, and now the next thing coming is the exponent on the 10, so we enter the 5. Now we're done entering that first number, but the calculator doesn't know it yet. However, as soon as we enter an operation key, like multiplication, division, etc., the calculator will know that we're done entering the number, and it'll be stored in the calculator. So the next keystroke is the divided by button. Now that first number is stored in the calculator, and the calculator is ready for the next number, which is just a 17. Now we hit the 17, and the display will look like this. We're done entering numbers, so we can hit the enter key, and the calculation will be done. In a previous lesson, we had learned how to put the calculator in scientific notation mode with 3 significant figures, and that's the way this answer is displayed. Let's do another problem. This is the multiplication of two numbers, both of which are in scientific notation, and both of which have negative exponents. So let's run through the keystrokes. 1.87 second, EE. Now the next thing coming is the exponent on the 10, but it's a negative exponent, so we have to use that little minus sign wrapped in parentheses down there. That's how we do our negative exponents. And then the 6. We want to multiply that by 6.53 second, EE, minus sign wrapped in parentheses again, 8. We're done entering the numbers. We can do the calculation, hit the enter key, and now we can see the answer to this. There it is in the lower right of the display. Be careful to watch for the minus sign on your exponents. It's pretty small and easy to miss in your answers at the end of your calculation. Notice how when we did this problem, we did not have to use any parentheses in entering any of the numbers. By using that second EE keystroke combination, we tie those numbers together, and all we have to do is enter the numbers. The only parentheses are the ones on that key for the negative exponents, and we didn't actually have to enter those. Time for another problem. This is a division problem with both numbers in scientific notation, and let's see how the keystrokes work out for this. 5.91 second, EE, 5 divided by 9.62 second, EE. Now note that the denominator has a negative exponent there, so I have to use the minus sign wrapped in parentheses. And then 6. I'm done entering the numbers. All I have to do is hit the enter key. And here's my answer. 6.14 times 10 to the 10th. Notice on this problem again, I did not need to wrap anything in parentheses. Because of the way scientific notation works, I just entered the numbers with a division sign between them. Easy as can be. Now let me show you a wrong way to do that problem. There's our answer on the previous one. 6.14 times 10 to the 10th. Okay, this is the same problem, but I'm going to use it using different keystrokes that seem like they ought to work. So here we go. 5.91 times 10 caret 5. That would be 10 to the 5th. Notice this time I did not use the second EE keystrokes that we've been using. Instead, I used keystrokes that might be what you thought you might use to make it look like what you write. Continuing on here, divided by 9.62 times 10 caret, it's a negative exponent, so I use the minus sign wrapped in parentheses, 6, and enter. You may not have noticed, but we had to do 2 extra keystrokes entering the numbers this way. So, how did the answer work out? We get 6.14 times 10 to the minus 2. When we did it using the second EE method, we got 6.14 times 10 to the 10th, which happens to be the correct answer. What went wrong? I'll let you try to figure that out, but I'll give you a hint. It has to do with order of operations. So, the moral of the story, first, don't use the times 10 caret for scientific notation, and use second EE instead. I guess that makes 2 morals to the story. By the way, it would have been possible to get the correct answer to that last problem if we had carefully wrapped things in parentheses, although that would have meant even more parentheses, so much work. And then it also would have meant having to remember things carefully. Let's do one last problem. This is one that brings up a potential error that almost everyone who uses a calculator has made at one time or another. Try this one out on your own, and then I'll work through it. Go ahead and pause the playback now. Okay, let me step through the problem here. 9.87 second EE8 divided by 1 second EE6. That may differ from what you had. Enter, and the answer is 9.87 times 10 to the second. Did you by any chance get 9.87 times 10 to the first, which would translate to 98.7? That's what I would get if I'd made the common error on this. And believe me, I've done it, so I've made the error enough times that now I watch out for it. So what's the problem? First, something obvious. 10 to the 6th is the same as 1 times 10 to the 6th. Multiplying a number by 1 doesn't change it. Well, 1 times 10 to the 6th is the way we usually write things in scientific notation. However, when you look at that 10 to the 6th all by itself in the denominator, it's very tempting to think 10 EE6, and that's what happens. But that 10 to the 6th does not mean 10 times 10 to the 6th. So if you do that, think of that as 10 EE6, you end up dividing by something that's 10 times too large, and you get an answer that's 10 times too small. You would get the 9.87 times 10 to the first. So 10 times 10 to the 6th is actually 1 times 10 to the 7th, or just 10 to the 7th. So watch out for that. Be careful for those naked powers of 10. That's it for this lesson. A further lesson will show some more complex calculations using scientific notation. And for that lesson, I combine this calculator presentation with that for the TI-83 and 84 because the keystrokes end up being almost identical on the 2 calculators, and it's a little more efficient to do that. So, we're done for this one.